This experiment we want to find out the wavelength of the laser light. Basically this is the laser source. अगर आप यहाँ पे देखें तो wavelength of this light is written over here 650 nanometer. So by the experiment, this is a grating experiment. By the help of this experiment we want to find out the wavelength. So for this we require the laser source, grating element and the screen. Okay, so the formula for to find out the wavelength, we have simple formula d sin theta is equal to n times of lambda, where n is the order of diffraction. So from here lambda equal to we have d sin theta upon n. Okay, this is our formula. So what is d? D is basically 1 upon capital N, which is written over here. You can see on this grating element, it is written over here 600 line per mm. So when I see 1 upon 600, it is comes out to be d 1 upon 600 line per mm. So we convert it into 1 upon 6000, it is become centimeter, 1 upon 6000 centimeter. Okay, these are the number of line per centimeter. Now what we need to find out, sin theta. So what is the formula for sin theta? For a small angle sin theta is nearly equal to theta. So theta equal to we have x mean this distance, this is the central maxima. Here we get the first maxima. So this distance is basically, you can say dy, let's say I am considering this y. So this is our source, this is the screen. So the distance between source and screen is y, and from here to here this distance is basically x I am considering. So our sin theta become x upon y. So this theta equal to x upon y. So x upon y is the value. So y is distance between this grating element, and this is your screen. Okay, so this is grating element and this is your screen. I hope you understood this. So now measure these distances. So I am using a scale here. So by the help of scale, when I measure this distance, it is nearly comes out to be 10.9. So y is 10.9 and x, where is the first order maximum we get? So almost when you do the calculation, it comes out to be 4. Okay, so the distance from here to here, you can see from the central maxima to first, it is nearly almost equal to 4. So this distance equal to 4 centimeters. So when you solve it, the value of sin theta is 0.36697 something. Now lambda equal to, you have to divide 0.36697 by 6000. Okay, so once you divide this, you get around 6.116 into 10 to the power minus 5 centimeter. So I can write it 611.6 into 10 to the power minus 7 centimeter. Now you want to convert it into nanometer, so multiply it by 10 to the power 7. So your answer becomes 611.6. Okay, this is approximately I am getting nanometer. So our calculated value is how much? This is my calculated value, and you can see my experimental value is exact value is 650 nanometer. So here you can find out the percentage error, that is the true value 650 minus your experimental value, which is nearly equal to 612 upon experiment this true value into 100. So if this percentage error less than 10, we can accept this experiment. Okay, so try to minimize this experiment, try to minimize this percentage error such that you get better results. So thank you, I hope you understood.